This is the Sun we will see in 5 billion years. At this point, the Sun has expanded more than 200 times in size. It will soon completely consume the Earth. This is the ultimate fate of the Earth, the end of the Sun's life. It will also mean the end of the Earth. The Sun is in the main sequence stage. The Sun has burned steadily for 4.6 billion years. In about 5 billion years, the Sun's core will be depleted of its hydrogen fuel. Fusion will stop at the core. By that time, there won't be enough energy to maintain gravitational equilibrium, causing the Sun to expand dramatically to 200 times its current size. Maintain gravitational equilibrium, resulting in a dramatic expansion of the Sun's size to more than 200 times its current size. Into a red giant phase, surface temperature drops. Color changes from yellow-white to reddish-orange. In the process, Mercury and Venus are swallowed up by the Sun, melting and gassing at high temperatures. The Earth, though temporarily on the brink of the Sun's expansion. But as the Sun's radiation intensifies so dramatically, the atmosphere is stripped away. The oceans boil and evaporate, and the biosphere collapses, and ends up in a blistering inferno. The biosphere will collapse and eventually become a hot, barren inferno. As the thermonuclear reactions periodically go out of balance, the Sun will enter a pulsating phase of expansion and contraction that will last for hundreds of millions of years. The unstable cycle of expansion and contraction. During this process, the Moon will be torn apart. The Earth will eventually be swallowed up by the Sun. The Earth's crust is melting in temperatures of more than 3,800 degrees. The once vibrant blue planet will be buried in the Sun's plasma fire. At the end of the pulsating phase, the Sun's outer layers of material are separating from the core, with the outer layers being ejected through the material. The outer layers are ejected through the material to form colorful planetary nebulae, which are dispersed throughout the universe, and become the raw material for new stars and planets. While the remaining core is gravitationally collapsed into a dense white dwarf. The white dwarf balances gravity on the pressure of the ice-reducing electrons, although it no longer undergoes fusion. It still emits a residual heat and light over trillions of years, until it loses all of its heat and eventually cools to a cold, dark, silent black dwarf star, born from the collapse of a molecular cloud, to evolve into a white dwarf and eventually die out. This is the life of the Sun. The death of the Sun is a slow process lasting billions of years. In fact, humans may not have to wait 5 billion years, about 2 billion years, for the Earth to become uninhabitable. Because the Sun's brightness increases by about 10% every 1 billion years, this seemingly slow change would have devastating effects on the Earth, by which time the temperature of the surface would have risen by about 300 degrees Celsius. By then, surface temperatures will have risen to around 300 degrees Celsius. The oceans will gradually evaporate. The atmosphere will also be stripped away by the stellar winds. In these extreme conditions, all complex life will become extinct. Unless humans master interstellar migration before then, humanity has only about 1 billion years or so left.